Alright, welcome to the next video. This is section 11.6, adding and subtracting rational expressions. So it's a pretty strong continuation from the previous section, which was how to reduce or simplify when you're dividing rational expressions. Because in order to recombine them back together, you need to have a common denominator. So this section is kind of really more about finding common denominators than adding and subtracting. So first thing is least common multiple. So the LCM, or least common multiple, is the smallest number that both of your expressions go into evenly. So that means it has to be at least as big or bigger than either of your two expressions. So if I said, like, I've got an 8 and a 10, what's the least common multiple of 8 and 10? Well, what's the smallest number that both 8 and 10 go into? The answer is 40. 8 goes into 40 5 times, and 10 goes into 40 4 times. So 40 would be the least common multiple. And notice it's a bigger number, basically, than either of these. There is one way to always find a common multiple, and that's to take your two expressions and multiply them together. If you multiply them together, you get 80, which is a common multiple, but it's not the least common multiple. So you can always just use a common multiple by multiplying these two together, because they're guaranteed to both go into the expression if you multiply them together, because they're both factors of it. But the least common multiple is going to be the smallest number possible that still achieves that. Okay, second thing, least common denominator. The least common denominator is just the LCM of your denominator. So if you were doing multiple fractions together, like for example 1/3 plus 2/5, right? In order to add fractions, you have to have the same denominator. Okay, so you look at this denominator, which is a 3, and this denominator, which is a 5, and you say, what's the lowest common denominator here? 3 and 5 is going to be a 15. Okay, so then you get a common denominator by multiplying this guy by whatever's missing to make the denominator 15. So it's going to be a 5 over 5. You multiply this guy, whatever's missing, that's going to be 3 over 3. And so we get, in the first one, 5 over 15, plus in the second one here, 6 over 15. And we add those together. Numerator is going to give me 11/15. So that's a quick and dirty review of probably elementary school or maybe 7th grade, adding fractions with unlike denominators, find the lowest common denominator, and then add them like normal. So in this class, we'll be extending this to include variables. So problem solving tips, bam. Find the lowest common denominator, and then multiply top and bottom of each term by the missing part. Going back a slide, again, we found the lowest common denominator here. Then we multiply each term, top and bottom, by whatever was missing to give it that lowest common denominator. Second thing, only add or subtract terms with the same denominator. So if two things have unlike denominators, you absolutely cannot add or subtract them until you find that common denominator. Once you do have a common denominator, you're going to add or subtract the numerator only. Okay, only the numerator. The denominator stays the same. Think about pieces of pie. If you have, 3 slices of pie and I have 5 slices of pie and we add them together, we have more, but they're still the same size slice of pie. So the denominator of the fraction basically tells you how big each piece is, and the numerator tells you how many you have. So you're adding and subtracting to the numerator, but you're keeping the denominator exactly the same. Okay, notice how this whole technique, finding a common denominator, is the exact opposite of the butterfly technique. In the butterfly technique, you start with a fraction already put together, and you're trying to break it apart into separate fractions that are added together. Okay, in this common denominator technique, you start with a whole bunch that are all separate. You try to get the common denominator, and then you try to squeeze them all together into one big fraction. Okay, note that sometimes your lowest common denominator, you just have to multiply by -1. For example, if you have 3 over x minus 2, and you're adding to it 5 over 2 minus x, this denominator here, x minus 2, and this denominator here, 2 minus x, they're exactly the same except for a minus sign. So if you just factor out a minus sign or multiply the top and bottom by a negative sign, now they're the same. Okay, so 3 minus 5 is -2, and now the denominator is the same. It's going to be x minus 2, because like right here, if you distribute the minus sign in, you get a -2 and a positive x. Okay, so just be aware that the denominators might look a little bit different, but you don't want to find a bigger common denominator than you need to if they're just off by a minus sign. And lastly, always reduce fractions as much as possible before finding the lowest common denominator. So the last thing you want to do is get some big nasty common denominator when you could have just simplified the fraction to begin with. So let's do some example problems. First of all, if the denominators already match up, it's ridiculously easy. You just add the numerator. So 2y plus y is 3y over 5. Again, ridiculously easy. T plus 3 minus t, the t's cancel out. We get 3 over 7. And lastly, x plus 2 plus x plus 5, 2x plus 7 over 3. Denominators already match up, super easy. Find the lowest common multiple of each pair of polynomials. Okay, 4 and a 12. What's the smallest number that 4 and 12 both go into? That's going to be 12. Okay, now we got x squared and x. What's the smallest amount of x's that both of those go into? That's definitely x squared. X squared goes into x squared, and x goes into x squared. How about y's? I got a y here, and I got a y squared here. So the smallest thing that they both fit into is going to be y squared. When you're dealing with the variables, you just have multiples, so this is how you do it. Okay, how about here? You got 2r minus 1 and r plus 4. What's the smallest thing they both fit into? Well, they have nothing in common, so to get the lowest common multiple, you're going to have to multiply them together. So 2r minus 1 multiplied by r plus 4. That right there, my friends, is your lowest common multiple. Now, I actually do not recommend that you multiply these out and FOIL it. You should leave it in factored form like this, because then it makes it easy to see which pieces are missing which parts. It'll make a lot more sense on the next slide for examples. Alright, let's add these two together. This has an r squared, this has a 4r. The lowest common denominator between a 4r and an r squared is like a 1 right here, yeah? So a 4 and a 1 is going to be a 4. An r and an r squared is going to be an r squared. So this one has the 4r, but it's missing another r. So I have to multiply top and bottom by r. This one has the r squared, but it's missing the 4. So I have to multiply top and bottom by 4. Okay, so what do I get here? I get 5 times r minus 2 times 4, which is 8. And in the denominator, I've got 4r squared right here and 4r squared right here. So the denominator stays the same, it does not change. So there we go. Add in two things with unlike denominators. Let's do one more over here. This is a y squared, this only has a y, so I need to add another y right here. If I add a y to the bottom, I have to add a y to the top. Technically what I'm doing is I'm multiplying top and bottom by y over y. The denominator here is now 9y squared. Here it's only 3y squared, so this one I'm missing. How do I get from 3 to a 9? I gotta multiply by 3, top and bottom. Okay, so what's in my numerator here? 3 times 5x. That's going to give me 15x minus 2xy. 2xy. In the denominator, I got a 9y squared here, got a 9y squared here, so my denominator is 9y squared. Okay? When the denominators are monomials, it's pretty straightforward. You just figure out what the lowest common denominator is and give each piece whatever it's missing. Now, when the denominators are polynomials or binomials, this sucks. Okay, you got x plus 2 here, you got an x minus 1 here. So the lowest common denominator is going to be the product of x plus 2 and x minus 1. So the reason you leave them separated is because the second piece here, it has the x minus 1, it's missing the x plus 2. So multiply top and bottom by x plus 2. This one has the x plus 2, it's missing the x minus 1. So we put in the x minus 1, put in the x minus 1. Okay, so now multiplying the top, we've got to distribute here. We got x squared, x times negative 1 is negative x. Over here we got to distribute the 4, but I'm taking that stuff there from the first piece, and then I'm subtracting, god darn, I'm subtracting, what am I subtracting? Distribute the 4 into the x, you got a 4x, and then distribute the 4 onto the 2, got plus 8 close parentheses, and now in my denominator I got that x minus 1 multiplied by that x plus 2. Okay, let's head this way. So in the numerator I've got x squared, okay, minus x minus 4x, that's going to give me minus 5x, and then over here I've got minus 8, so minus 8, and then in the denominator I still have my x minus 1 and my x plus 2. Okay, so this is a pretty good final answer. If the numerator was factorable, then I would want to factor it, but the only way to get an 8 is a 8 times 1, which will not give me a 5, or a 4 times 2, which will not give me a 5. So the numerator is not factorable. If it were factorable, I should definitely factor it, because maybe it will cancel some of this stuff out. The back of the book, I suspect it might actually multiply this out, and it might give you x squared minus 5x minus 8 divided by, if you FOIL this out, you're going to get x squared. Inners is negative 1x, outers is plus 2x, so plus x, and then negative 1 times 2 is minus 2. So it's quite possible that the answer will be in standard form when you're checking in the back of the book. And if so, you need to do it. I mean, it's not my preference one way or the other, which is better or worse, but if the back of the book is given it to you like this and you want to check your answers, well, geez, you're going to have to do that. Otherwise, you're not going to be able to check your answers. And as we all know, checking our answers is incredibly important so that we know if we're making mistakes or if we're totally understanding what we are doing. Okay, let's try 19 and then wrap this video up. First thing I notice is that this denominator is a trinomial, and I'm hoping that maybe I can factor it and cancel out this p plus 1. But if not, hopefully I can factor it out and one of the factors will be the same as this right here. So let's put my p plus 1 in the numerator. In the denominator, let's factor it. Okay, so what do I have? I've got p, and p multiplies to negative 4, adds to positive 3. That's going to be a p plus 4 and a p minus 1. So the p's don't cancel. That's all right. Over here I've got a p, and then I've got a p plus 4. Okay, so when I want a common denominator, they both already have a p plus 4. So this one, to get the same thing as I have over here, is going to need a p minus 1 added on. And if I add it to the bottom, of course, I got to multiply the top by the same thing to keep it balanced. Okay, now let's distribute here. I got p plus 1, p plus 1. Now over here I'm going to go p squared, and p squared there, and then p times negative 1 is minus p. That's pretty cool. Then over here I got my p plus 4 multiplied by my p minus 1. Keep it going, keep it going. Now this p right here is going to cancel out with this p right here, and that gives me my final answer, which is p squared plus 1 over, let's multiply this out. I'm going to go with the p squared plus 3p minus 4. Right back to where I was. Notice, right back to where I was over here. Okay, final answer right there. So, if you haven't noticed yet, you're going to get a boatload of practice factoring and foiling quadratics, which helps reinforce what was so important back in chapters 8 and 9 when we spent a ton of time working on this. So keep on practicing factoring and foiling your quadratics and you'll be in good shape. That's it for this video. I'll see you in class.